This is the lesson for, this is 3.8 and 3.9. Here's the homework that goes along with it. Answers to last night's homework if you need it. All right. Section 3.8. This is a review. Every positive number has two square roots. Two square roots. This is going on your regular paper. What is the square root of 16? Who can tell me? What's the square root of 16, Lexi? It is 4. Positive 4 and negative 4. And the reason that is 4 times 4 is 16 and negative 4 times negative 4 is 16. The positive root is called the principal. Square root. Now, you can use this symbol to represent positive and negative, plus and minus. Just like I did there. All right. Now, what is this one? Negative root 1 over 25. I'm going to have a negative. I'm going to carry it along. What's the square root of 1? Everybody? 1. What's the square root of 25? Negative 1/5. Done. Now, this one. Plus and minus root 0. What is the square root of 0? 0. Is 0 positive or negative? No. It's neither. It's neutral. It's just 0. Now, here we go. Find all square roots of 0.81. What are the square roots of 0.81? Go. Plus and minus 0.9. Because 0.9 times 0.9 is 0.81. Aha. No real answer. There is no number that you know right now that you can multiply by itself to give you negative 36. That is not possible when we're talking about real numbers. In Algebra 2, you will learn that that's the imaginary number, but we're not worried about that right now. Now, between what two consecutive integers is the square root of 105? Well, isn't the square root of 100 a perfect square? And the square root of 121? Isn't 105 in between the square root of 100 and the square root of 121? What is the square root of 100? 10. But we need to put a negative out in front. So negative 10. And what's the square root of 121? 11. So negative 11. So the square root of 105 is between negative 10 and negative 11. What about the square root of 201? What two perfect squares is that in between? And if you know your perfect squares, this makes this easy. 196 and 225. The square root of 196 is 14, and the square root of 225 is 15. Now, we're going to estimate this. Square root of 21. Isn't that between the square root of 16 and the square root of 25? Okay. The gap from 21 to 25 is 4. The gap from 16 to 21 is 5. So 21 is a little bit closer to 25. Give me a decent estimate for the square root of 21. What do you think it'll be? Justin. What's the square root of 4? Or square root of 16? 4. What's the square root of 25? So it's between 4 and 5. 4.6. Estimate 4.6. I'm going to use a calculator here. The square root of 21 is 4.58. Justin was very close with 4.6. Okay. Now, we're not going to do that one. We did these problems till the cows come home early in the year. How do I write negative 4 cubed in this form without parentheses? Thomas.
Negative 4 times 4 times 4.
Correct. Because 4 is being cubed. This will be negative 64. How do I write negative 5 in parentheses cubed, Lexi? Correct, because we are cubing negative 5, which ends up being negative 125. How do you read that problem? How do you read that problem, Casey? Cube root of 27. That means, what are you going to multiply by itself 3 times to get 27? What is it?
This is George. Please dial the office.
Yes, 3 times 3 times 3 is 27. So the cube root of 27 is 3. What about the cube root of negative 8? Lexi? Correct, because negative 2 times negative 2 times negative 2 is negative 8. Very good. All right, enough of that. We are going on to the Pythagorean theorem. You do not need to write this part down right now. There was a guy 2,500 years ago named Pythagoras. He studied right triangles. And when he studied right triangles, he came up with what we call today the Pythagorean theorem. Draw this picture on your notes. Draw a right triangle. I know it's a right triangle because it's got a right angle right there. Okay, we've got a right triangle here. We know that because that little box is a right angle. While we're at it, what do the 3 angles in every triangle in the world add up to, Justin? 180. That is a fact we already know. This is 90. So what do these two together have to add up to? None. Okay. So that is going to be the biggest angle in the triangle, because these two together are 90. Now, the 2 sides that form the right angle are called legs. That's a leg, that's a leg. The side that is opposite the right angle is called the hypotenuse. Hypotenuse. Okay. Now, when we are learning about a right triangle, the Pythagorean theorem is a squared plus b squared equals c squared. Write that down, and it needs to be lowercase. I don't know why, that's just the way it is. Okay? But the Pythagorean theorem is a squared plus b squared equals c squared. This is the relationship among the sides of a right triangle. The legs are A and B. Now, you could call this leg A and this leg B, or this leg A and this leg B. It does not matter. A and B are interchangeable with the 2 legs. The hypotenuse has to be C. Has to be C. So, on your Pythagorean theorem quiz, I am literally going to have you draw this same picture. I'm going to ask you to name the 3 sides. Leg, leg, hypotenuse. Tell me what variable goes with them. A, B, and C. That's 6 points. And then 4 points for the Pythagorean theorem. Easy peasy, lemon squeezy. You have to know that to be able to do these problems. Now, what is special special about the hypotenuse? It is always the longest side of a right triangle. Why do we know that it's the longest? Because it is located across from the right angle, which is the biggest angle. 90 degrees has to be the biggest angle in this triangle. It's not in your notes. I know. That's why I gave that piece of paper. It is located across from the right angle, which is the biggest angle. So think about it. If I've got the biggest angle, isn't that going to spread that side out to be the longest? Now, let's look at this. That's the Pythagorean theorem. I already wrote that down. Okay. Let's jump to your notes now. In your note packet, this problem says 5 and 3. You see that in the notes? Okay. So, when you see a problem like this, and it says find the missing side, the first thing that should fly into your head is, look, that's a right angle, so this is a right triangle, so we know that in a right triangle, the sides are related by using the Pythagorean theorem. A squared plus b squared equals c squared. I want you to get in the habit of writing that down for every problem. Now, take a look at this triangle. What are these two sides called? What are they called? Legs. So I'm going to call this one A and this one B. It doesn't matter. You can call 5A and 3B, or vice versa. They are the legs. What letter goes here? C. It is the hypotenuse. We don't know what C is, so we're looking for C. So let's go back to our formula. So 3 squared plus 5 squared equals C squared. Now, when you are solving this, you must square before you add. Take care of the exponents. So 3 squared is 9, plus 5 squared is 25, equals C squared. 9 plus 25 is 34, equals C squared. We are not done. We do not want to solve for C squared. We want to solve for C. So I'm going to take the square root of both sides. You can do anything you want in a equation as long as you do it to both sides. Isn't the square root of C squared just C? Because C times C is C squared. So you're going to use your calculators. The square root of 34 is approximately 5.8. I'm going to put a little dot over my equal. That means approximately, because 34 is not a perfect square. It will go on forever and ever. It is irrational. Remember that? Irrational. All right. That is given two legs, finding the hypotenuse. Now, this one, in your homework or notes, that's 13 and that is 12. Now, look at this one. In this one, I'm given the hypotenuse and one leg, and I've got to find the other leg. Again, I look at this and I say, oh, right triangle. Well, that means I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. I'm going to call this A, this B, and 13 is C. Make sure C goes in the hypotenuse. C is the hypotenuse. Now, let's substitute. We don't know A. B is 12 equals C squared. Now, solving this is very similar. A squared